analysis through run signature, what we do with all of our runners that come into the lab is we look at daily movements of lunging, walking, squatting, and walking down the stairs and create a baseline using sock running. And then we basically take that baseline and we compare how someone's movement profile changes from their daily movements or activities of daily living, if you will, to running. And we believe the closer that someone stays to their habitual motion path, the better it is for their body and the better it is for their performance. And what we can do from that is, you see here in red, running movement, and in this purple color, habitual daily movement. This is what we call a deviation score. And this particular one is just highlighted for the knee, for total internal rotation, transverse plane knee rotation. And you can see a fair bit of differentiation between running and habitual daily movement. I wouldn't call that bad. I would call that different. And our goal is to put someone into shoes that make their movement profiles more similarly matched, right? On the right-hand side, you can see that a better match. And we can use that by optimizing that shoe-person connection. So why do we believe this is important? Well, because we are partnering, as we mentioned, with a number of different outside institutions and our internal research team. One of the studies we worked with was this study that looked at an MRI scan of an individual both before and after running, and then individuals who are moving close to the habitual motion path, or people who've deviated fairly significantly. And you can see that cartilage degradation, or cartilage inflammation, I should say, was higher in individuals who moved further from their habitual motion path during exercise, during running. We've also done some extensive exercise physiology work in the lab and looked at energy costs, and people who move further away from their habitual motion path tend to perform less efficiently metabolically. So here at the lab, we test people running in the lab with force instrumented treadmills and motion capture, and sometimes exercise physiology tools like VO2 max assessment. And we do this mainly for running, but certainly for walking. We then analyze using the habitual motion path paradigm and run signature, how someone deviates from or away from their ideal habitual motion path for a given shoe that they're wearing. And then we apply those learnings to improve our test and redevelopment cycle for any given shoe that's in development. So we create, if you will, an early stage prototype. We evaluate that biomechanically. We take the feedback. We make tweaks and improvements and enhancements, or sometimes completely redesign the shoe and compare that to previous models of the shoes and to competitor shoes to optimize performance. So in that effort, we have kind of a hierarchy or a paradigm set up, a continuum, if you will, from neutral through to support, through to fully assisted transition. And we think about habitual motion path as a really key indicator of whether someone is in the right shoe for them, right? And this paradigm really looks like this in our product currently.